In this video, we're going to cover a couple examples of solving quadratic equations by factoring. Just to remind you that when we solve these equations, the first thing we do is we set the equation equal to 0, then we factor the resulting polynomial, and there are several ways of factoring polynomials. You should have several of these techniques in your bag of tricks, but some very common ones are to look for a GCF, to find the difference of two squares or dots. AC method is very common with trinomials that don't have a leading coefficient of 1. Factor by grouping is used for 4-term polynomials, and simple trinomials are ones that are pretty easy to solve. After you factor the polynomial, you should use the zero product rule. That's where you set the factors equal to 0, and then you solve each of these equations. So let's do a couple examples now. Here we have 3y squared equals 5 minus 14. First thing we need to do is set this thing equal to 0 so that we can factor it. So I like to have a positive squared term, so I'm going to keep the 3y squared, and I'm going to get these other terms to come over on the other side. So I'm going to add 14y to both sides, then I'm going to subtract 5 from both sides, so I get that as my polynomial. This is a very important step. If it's not equal to 0, it doesn't do any good to actually factor this. The next step is to then factor. Now here we're going to use the AC method. AC is negative 5 times 3, which is negative 15. So you want to find the factors of negative 15, which will then add up to 14. We're going to list all of them, even though you don't really need to do this. Negative 1 times 15, negative 3 times 5, negative 5 times 3, negative 15 times 1. And I hope you can see very clearly that this one has a sum of 14, of positive 14. So this is really the one we want. So we're going to break up this using the AC method. 3y squared minus 1y plus 15y minus 5 equals 0. Again, we got the minus 1 from here and the positive 15 from there as well. Now we're going to use factor by grouping. The GCF of the first two terms is y. Y times the quantity 3y minus 1. Find the GCF of the second two terms, and that's positive 5. 5 times the quantity 3y minus 1. And this is equal to 0. Now it's very important that you just pay attention to whether these binomials are the same. If they're not the same, you cannot factor by grouping. Or maybe you made a mistake. So the resulting factoring is y plus 5, which comes from here and here, y plus 5, times the quantity 3y minus 1 equals 0. And now we're going to use the zero product rule. The zero product rule is basically taking each of these factors, blank times blank equals 0. So each of these, y plus 5 might equal 0, or 3y minus 1 equals 0. And then you solve both of these. In this case, y equals negative 5. In this case, 3y equals 1, or y equals 1/3. So here are my final answer for the equation. Let's try another one. This one's a little messier. I've got lots of k's going on, so I'm going to use actually several factoring techniques to solve this one. Again, first you set the equation equal to 0. 9k cubed plus 30k squared minus 24k equals 0. Now, this is a trinomial, but you don't want to jump into the AC method. You always want to look for a GCF. And in this case, the GCF, what can go into 9, 30, and 24? That's 3. What can go into k cubed, k squared, and k? That's k. So the GCF is actually k. I'm sorry, 3k. 3k times 3k squared is 9k cubed. 3k times 10k is 30k squared, and 3k times a negative 8 is negative 24k. Whenever you do factoring, you always want to just kind of multiply out in your head to make sure that if you were to actually multiply this, you would end up with the original line. It's always good to multiply while factoring. Now, here is a trinomial, which we can factor using the AC method. In this case, AC is 3 times negative 8, which is negative 24. And if you want to list all the factors of negative 24, you don't have to list them, but we could say negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. Yeah, 5 can't go in, 6 can go in, negative 6 times 4, and then it repeats. Negative 8 times 3, negative 12 times 2, and lastly negative 24 times 1. When you use the AC method, you really don't need to write all of the factors. You just need to write enough of them, or at least think of enough of them, because our goal is to get a positive 10. And which of these adds up to a positive 10? It's this one right here. The sum of these is a positive 10. So we want a negative 2 and a positive 12. I'm going to switch to brackets here. 3k, and now I'm going to put this whole thing in brackets. Let's break up this trinomial using this from the AC method. 3k squared, now plus 10k, we're going to break up into a minus 2k plus 12k minus 8. And now we're going to factor by grouping. 3k. The GCF over here of these two is k. K times 3k minus 2. GCF of this is plus 4. Plus 4 times 3k minus 2 equals 0. And to finish up the factoring, we have 3k times the quantity k plus 4 times the quantity 3k minus 2 equals 0. And now we're going to use the zero product rule. Again, the zero product rule is used when you have several things being multiplied and the product is 0. So this could be 0, this could be 0, or this could be 0. So we actually write equations for all of these. 3k equals 0, or k plus 4 equals 0, or 3k minus 2 equals 0. And then we solve each of these. This one we get k equals 0. Here we get k equals negative 4. And here we get 3k equals 2, or k equals 2/3. And this is our final answer for this problem.